Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we have been provided with an oblique cube which is having h is equal to 30 millimeter, and this cube, it rests with one of its edges on the horizontal plane in such a way that one of the square faces which is containing that h, it is inclined at an angle of 30 degree with respect to the horizontal plane. So this means that the base of the cube, it happens to be inclined at an angle of 30 degree with respect to the horizontal plane, such that when the base is tilted or the solid is tilted at an angle of 30 degree, it should be resting on one of its edges onto the horizontal plane. Now let us evaluate the orientation of this cube as it is going to rest onto the horizontal plane on its base. So if we choose this orientation of the cube, now we will find that when the base of the solid is inclined at an angle of 30 degree, it will be resting on either this corner or this corner onto the horizontal plane. So no way the solid, when it is inclined with respect to horizontal plane, will be resting on one of its edges on the horizontal plane. So this is the incorrect orientation of the solid onto the horizontal plane. So here if we choose this orientation, now we will find that if we tilt the solid either in this orientation or in this orientation, it will be resting on the base edge CD, or it will be resting on the base edge AB onto the horizontal plane. So this way, this is the correct orientation of the solid. So now once we incline the solid in this orientation, so we will find that the solid is resting on the edge CD onto the horizontal plane, while the base ABCD, it happens to be inclined at an angle of 30 degree with respect to the horizontal plane. And then in the second iteration, we have been provided with the information that the edge onto which the solid is resting onto the ground or onto the horizontal plane, so this edge, this is further inclined with respect to vertical plane at an angle of 60 degree. So we are required to draw the orthographic projections of this oblique solid. So now to begin with, we have to draw the top view projections of this cube, which will be appearing as a square onto the horizontal plane. And these projections, that is the top view projections, will be drawn below the XY reference line. So we know the orientation of this particular cube onto the horizontal plane, that is these two edges, they will be perpendicular to the vertical plane. Why? Because once this solid is inclined, that is the base is inclined at an angle of 30 degree with respect to the horizontal plane, this solid will be resting on one of its base edges on the horizontal plane. So it should be resting on the edge CD. So now having drawn the top view projection of this cube, which will be appearing as a square having edge is equal to 30 millimeter, now we find that 1, 2, 3 and 4 points, they are the points which are lying onto the top face of this cube. So they will be marked on the outer side, while the points A, B, C and D, they are the points which are lying onto the base of this cube. So they will be marked on the inner side of the top view projections, which are appearing as a square below the XY reference line. So now we have drawn the top view projections of this cube. Now we want to proceed with the construction of the front view projections of the cube. So we know that the cube is resting on the base on the horizontal plane. So we can check B dash and A dash points, they will be lying onto the XY reference line over here. C dash and D dash points, they will be lying onto the XY reference line over here. Now we know that the height of the cube, it is also equal to 30 millimeter. So now we can draw the front view projections, which will be again appearing as a square onto the vertical plane. So here we are going to get 2 dash 1 dash over here. We are going to get projections 3 dash 4 dash as the top face projections over here. We can see 2 dash 1 dash, they will be coinciding with each other over here. 3 dash and 4 dash points, they will be coinciding over here as the top face. So 1 dash, 2 dash, 3 dash and 4 dash, these are 4 points corresponding to the top face of this particular cube, whereas A dash, B dash, C dash and D dash, so these are 4 points in the front view corresponding to the base of this particular cube. So now the front view projections as well as the top view projections of the cube, which is resting on its base A, B, C, D onto the horizontal plane, they have been obtained. Now we know that this cube is tilted in such a way that one of the square faces, that is A, B, C, D. So this is the square face which is containing this edge CD onto which this cube is resting onto the ground over here. So now we have to transform or rotate these front view projections in such a way that the base of this front view projections of this cube should be inclined at an angle of 30 degree with respect to the horizontal plane. So we have drawn a construction line over here which is inclined at an angle of theta is equal to 30 degree. So why we have marked this angle as theta? Because this edge B dash, C dash and D dash, A dash happens to be the true length of this particular cube. So now we have to transform this cube over here in such a way that this distance B dash, C dash should be drawn over here as true length, and now this height will be also equal to 30 millimeter. So this square projection we have just transformed at an angle of 30 degree over here. So the distance between C dash, D dash and B dash, A dash, it has been drawn over here. Similarly, the distance between C dash, D dash and 3 dash, 4 dash, again perpendicular distance has been drawn over here. Similarly, the perpendicular distance of this vertical edge, it has also been marked over here. So we have transformed the rectilinear distances from the earlier front view projections which we had obtained into the transformed view or the rotated view, in which the solid or a cube, it has been inclined in such a way that this square face A, B, C, D happens to be inclined with respect to horizontal plane at an angle of 30 degree, while this cube or a solid, it is resting onto the ground or the horizontal plane on one of its base edges, which happens to be edge CD over here. So C1 dash, D1 dash, it lies on the horizontal plane, and the base of this solid, it is inclined at an angle of 30 degree with respect to the horizontal plane. Now, having obtained the front view projections of this inclined cube, now we are required to obtain the corresponding top view projections corresponding to these 8 points. So the 4 points A1 dash, B1 dash, C1 dash and D1 dash corresponding to the base, they are available, and 4 points 1 dash, 2 dash, 3 dash and 4 dash corresponding to the top face of the solid, they are also available. So corresponding to these 8 points, now we are required to obtain the top view projections as they will be appearing to an observer who is going to look at the solid from the top. So now, as the observer is going to look at the solid from the top, now from these 8 points, 4 vertical projectors we are required to draw in the downward direction. So wherever we are going to obtain the intersection points of these 4 vertical projectors with the corresponding horizontal projectors which will be drawn through the 8 points of the previous plan projection view. So we will be obtaining the corresponding 8 plan projection points in the top view projections over here, corresponding to this inclined cube over here. Now let us evaluate all these 8 points in the top view projections. Now we can see there are 4 points which are available over here, 1A and D4, corresponding to first horizontal line, and then there are 4 points available over here, 2, B, C and 3. They will be available corresponding to the second horizontal line over here. It means that corresponding to these 4 points, 4 points of intersection will be obtained alongside this horizontal line, and corresponding to these 4 points, 4 points of intersection will be available over here. So let us first of all evaluate the points of intersection. Now we can see here we have got the points of intersection corresponding to the base points, that is A1 dash, B1 dash, C1 dash and D1 dash. So here we can check the vertical projector from A1 dash, wherever it intersects with the horizontal projector drawn through the point A, we obtain the point A1 over here. The vertical projector drawn through the point B1 dash, wherever it intersects with the horizontal projector drawn through the point B, we obtain the point B1 over here. Similarly, wherever the vertical projector line drawn through the point C1 dash, it intersects with the horizontal projector line drawn through the point C, we obtain the point C1 over here. Finally, wherever the vertical projector line drawn through the point D1 dash over here, it intersects with the horizontal projector line drawn through the point D. So this point of intersection provides us with the location of the point D1. So all the 4 points corresponding to the base, they have been located in the top view projections. Now let us evaluate the 4 points corresponding to the top face, that is 1, 2, 3, 4 in the top view projections over here. So now we can check. Here these are the 4 points of intersection corresponding to the top face. So let us name these points. Let us locate or label these points over here. So now wherever the vertical projector line drawn through 1, 1 dash. So here we have got the vertical projector line drawn through 1, 1 dash. So wherever it intersects with the horizontal projector line drawn through the point 1, we obtain the point 1, 1 in the top view projection over here. Similarly, wherever the vertical projector line drawn through the point 2, 1 dash, it intersects with the horizontal projector line drawn through the point 2, we obtain the point 2, 1 over here. Similarly, wherever the vertical projector line drawn through the point 3, 1 dash, it intersects with the horizontal projector line drawn through the point 3, we obtain the point 3, 1 over here. And finally, wherever the vertical projector line drawn through the point 4, 1 dash, it intersects with the horizontal projector line drawn through the point 4. So wherever this intersection is obtained, we obtain the point 4, 1 over here. So all the 8 points, they have been located in the top view. Now we should know which are the edges which we need to join. We need to join A1, B1, C1, D1 and A1. We also need to join 1, 1, 2, 1, 3, 1, 4, 1 and 1, 1. We also need to join A1 with 1, 1. we need to join B1 with 2, 1. We need to join C1 with 3, 1. And we also need to join D1 with 4, 1. Now, which of these edges will be drawn dark or the object line projections, and which of these edges they will be drawn dotted line or the hidden line projection? Now we can see, as we are going to look at the solid from the top, the farthest point happens to be C1 dash and D1 dash. So any edges which will be joined with C1 and D1 in the top view projection, they have to be drawn dotted. So this edge we can see C1 dash and D1 dash, this is lying farthest away from the observer. So unless those edges they fall into the boundary, all those edges in the top view, they will be drawn as dotted line. Now as we join all these edges, we can see we have joined A1, B1 and then C1, D1 and then D1, A1. So C1, D1, it is not visible to the observer because this is available with us farthest away from the observer. So this has been drawn dotted. Now we should have also drawn B1, C1 as dotted and A1, D1 as dotted. But we haven't drawn these two edges dotted. Why? Because these two edges, they are falling onto the boundary of the solid. So A1, D1 has to be drawn dark. B1, C1 also has to be drawn dark over here. Similarly, as we are going to look at the solid from the top, so 1, 1, 2, 1, 3, 1, 4, 1, it will be visible to the observer. So this has been drawn as object line. And we have also joined A1 with 1, 1, B1 with 2, 1, C1 with 3, 1 and D1 with 4, 1. So this way, the top view projections of this inclined cube, which happens to be inclined at an angle of 30 degrees with respect to horizontal plane, they have been obtained. Now, into these top view projections, we know that this edge C1, D1, so this is the edge onto which we can see over here, this solid or the cube is resting onto the horizontal plane. So there is no reduction in this edge. So C1, D1, it is still appearing to us as a true length over here. So C1, D1 is the edge onto which the solid or the cube is resting onto the horizontal plane, or it is resting onto the ground, while the face ABCD, it happens to be inclined at an angle of 30 degrees with respect to the horizontal plane. So this edge C1, D1, even though it is not visible to the observer from the top, but it is still the true length as it appears to us in the top view projections. Now, in the next iteration, we have been provided with the information that this edge CD, that is C1, D1, on which the cube is resting onto the ground, it is further inclined at an angle of 60 degrees with respect to the vertical plane. So we are required to transform or rotate this plan projection view, which we have already obtained, in such a way that this edge C1, D1 should be appearing at an angle of 60 degrees with respect to the vertical plane. So we could have tilted it this way, we could have tilted it this way. So we have chosen that the orientation of this plan projection will be changed in such a way that C1, D1 edge should be inclined at an angle of 60 degrees with respect to the vertical plane. So what does this mean? That this edge onto which it is resting onto the ground, so this edge is further inclined at an angle of 60 degrees with respect to the vertical plane. So since this C1, D1 edge, it is the true length, so the angle 60 degrees we have marked as angle phi. So now using the rectilinear distances, we have to rotate this plan projection view in such a way that this oblique solid will be available with us at an angle of 60 degrees with respect to the vertical plane now. So how we can have the rectilinear transformation of this plan projection view at an angle of 60 degree? So please check. We know the distance between C1 and D1. So this distance is already available with us and it is true length. And since this C1 D1 distance is true length, angle phi has been marked over here equal to 60 degree. So this distance C1 D1 we have marked along this 60 degree orientation of angle phi over here. Now having marked this distance C2 D2 over here, now we know that this edge and this edge, these two edges, they are perpendicular to C1 D1. So please check. C1 D1 and B1 31 and A1 41, these two edges, they are perpendicular to C1 D1. So what we can do from this point and from this point, we have to draw two perpendicular projection lines or the construction lines over here. The moment we mark these two construction lines perpendicular to C1 D1, or they will be appearing as C2 D2 over here. Now we know the rectilinear distances between D1 and 41, distance between D1 and 11, distance between D1 and A1 over here. So corresponding to these 2 points, so these 2 points will be located at this distance, these 2 points will be located at this distance, and these 2 points will be located at this perpendicular distance from C2 D2 over here. So corresponding to these 2 points, now you can see we have marked another 6 points over here. So please check. These 2 points, they refer to C2 and D2. And the moment we measure this distance perpendicular, we will be able to locate 1, 2 and 2, 2. This is 1, 2. This will be 2, 2. Similarly, the moment we measure this rectilinear distance over here, we will be able to locate A2 and B2 over here. And the moment we measure this distance, that is between D1 and 41, C1 and 31, so we will be able to locate points 3, 2 and 4, 2 over here. So this way, using rectilinear distances, we have been able to locate all the 8 points corresponding to the oblique solid when the base of the solid is inclined at an angle of 30 degree and the edge onto which it is resting onto the ground, it is further inclined with respect to vertical plane at an angle of 60 degree. So having located all these 8 points, now we can transform this plan projection view into this oblique solid over here. So once we have been able to obtain the plan projection corresponding to this oblique solid or the oblique cube, now the corresponding projections of the 8 points in the front view need to be obtained. Now how that can be done? We have got 4 points over here, 4 points over here. So corresponding to these 8 points, the vertical projector lines now we are going to draw. We can see we have drawn vertical projector lines starting from these 8 points and extended onto the elevation projection view. Now how the corresponding elevation points they will be obtained? Now here we can see there are 8 points in the elevation projection view which we had obtained previously. Now they are available in pairs. Now from each one of these 8 points, we are going to get 4 horizontal projector lines which we can draw over here. Now wherever these horizontal projector lines, they are going to intersect with the corresponding vertical projectors emerging from the plan projection points. So we will be able to locate the elevation projection points of all of these 8 points which will represent the front view projection of this oblique solid. So let us first of all evaluate the front view projections corresponding to these 8 points in the elevation view. So now here we have got the points 1, 1 dash and 2, 1 dash in the elevation. So from 1, 1 dash and 2, 1 dash a horizontal projector line we have drawn, and wherever it will be intersecting with the vertical projectors drawn through the points 1, 2 and 2, 2. We are going to obtain the points 1, 2 dash and 2, 2 dash over here. So please check. This is horizontal projector line drawn through 1, 1 dash. So wherever it intersects with the vertical projector line drawn through the point 1, 2. So here point 1, 2 dash will be obtained. Similarly, here we have drawn the horizontal projector line through the point 2, 1 dash of the previous elevation view. Wherever it is going to intersect with the vertical projector drawn through the point 2, 2. So this vertical projector and horizontal projector, wherever they intersect, they provide us with the point 2, 2 dash in the elevation. Similarly, here we have got points 3, 1 dash and 4, 1 dash. So once we draw a horizontal projector line through these 2 points, let us evaluate their point of intersections with vertical projector lines which are drawn through the point 3, 2 and 4, 2. So this is vertical projector line drawn through 3, 2. So this will provide us with the location of the point 3, 2 dash. Similarly, this is vertical projector line drawn through the point 4, 2. So this intersection of the vertical projector line drawn through the point 4, 2 with horizontal projector line drawn through the point 4, 1 dash, it provides us with the location of the point 4, 2 dash. So the 4 points corresponding to the top face, they have been evaluated. Similarly, let us evaluate 4 points corresponding to the base of the solid. So here we have another 2 points corresponding to the base, A1 dash and B1 dash. So let us draw the horizontal projector through A1 dash and B1 dash. So wherever this horizontal projector line, it intersects with the vertical projector drawn through A2, point A2 dash will be located. Wherever this horizontal line intersects with the vertical projector line drawn through the point B2, point B2 dash will be located over here. And finally, this is the horizontal projector line drawn through the points C1 dash and D1 dash, which are located onto the horizontal plane. So let us work out the intersection of the horizontal locus line drawn through C1 dash and D1 dash with the vertical projector line drawn through C2 and D2 over here. You can check, C2 lies here, D2 lies here. So once I draw the vertical projector through C2, wherever it intersects with XY reference line, we obtain the point C2 dash over here. Similarly, through D2, this is point D2 over here. Once we draw a vertical projector line through D2, wherever it intersects with the XY reference lines means horizontal projector drawn through the point D1 dash. So this gives us point D2 dash. So A2 dash, B2 dash, C2 dash and D2 dash, they have also been located. So 4 points corresponding to the base, 4 points corresponding to the top face, they have been located. And which are the edges which we have to join? We have to join 1, 2 dash, 2, 2 dash, 3, 2 dash and 4, 2 dash and 1, 2 dash. Similarly, we are also required to join A2 dash, B2 dash, C2 dash, D2 dash and A2 dash. And finally, we are also required to join 1, 2 dash, A2 dash, 2, 2 dash, B2 dash, 3, 2 dash, C2 dash and 4, 2 dash and D2 dash. But which of the edges will be drawn using object line? Which of these edges they will be joined by using the hidden line? That we need to evaluate. Now let us look at this plan projection view. So when the observer is going to look at this plan projection view from this orientation, A2 is the point which happens to lie farthest away from the observer or nearest to the plane. So anything joining A2 should be drawn dotted unless it is going to appear in the boundary. So let us join and we find that everything, there are 3 edges joining A2 dash. So all these three edges, they have been drawn dotted because they are not falling in the boundary. And rest all the edges we have drawn using the object line. So this way we can find that since the observer is going to look at the solid in the top view from this orientation, so A2 point is farthest away from the observer. So these three edges A2 dash, B2 dash, A2 dash, D2 dash and 1 2 dash, A2 dash. So all of the three edges which are going to be joining with A2 dash, they have been drawn using hidden line, because these three edges, they are not visible to the observer from this orientation. So this way we have been able to obtain the front view projections as well as the top view orthographic projections of an oblique cube which happens to be inclined at an angle of 30 degrees with respect to the horizontal plane, and the edge onto which it is resting onto the ground, that is the edge CD. We can see this is the edge CD over here. So this edge CD, it is further inclined with respect to vertical plane at an angle of 60 degrees. So this way the orthographic front view projections of the oblique solid and the orthographic top view projections of this oblique solid, they have been appropriately obtained into this situation. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of an oblique solid which happens to be inclined with respect to the two reference planes, that is horizontal plane and the vertical plane. So we will be continuing with further discussion regarding few more illustrative cases of the projections of the oblique solids in the coming lectures. So thank you very much. Thanks a lot.